and it's coming down, or you can say that it's coming down in this direction. Okay. Now, if you use method number 1, right, you use visualization. Okay. You know that the 150 is here, the 10 inches is here. So you know, you can also say that, hey, moment about Z is going to be equal to 150 multiplied by what? 10. And this is also 1500 pound inch. And you know that this is compression, and this is what? Tensile. Now, this technique that I'm showing you now is method number 1. This over here, okay, is method number 2. You use static analysis. You decide which one you are more comfortable. Okay, if you are more comfortable by using static analysis, do it. But you have to know what is your positive shear, what is your positive bending moment direction. Are we clear? Okay. Now, if you look at this XY plane, is there any other forces for you to analyze? The answer is no. Okay. So, i.e., ignore, okay, do not analyze. Okay, do not analyze the dots and the crosses. The dots and the crosses means all this. Okay, so these are the crosses and these are the dots. You only analyze the arrows. Okay, you only analyze the arrows that look like this. Okay, you only analyze the arrow that look like this. Are we clear? Okay, you don't analyze the dots and crosses. Okay, so now we have discovered we have a moment in the Z direction. Okay, and the moment of Z direction is in this orientation, which is compression and tensile. Okay, right. So the next thing that we are going to do, right, and this is what I prefer to do. Okay, and I hope you will adopt this methodology. Is once you know that MZ at point A is equal to 1500 pound inch, right? So we know that the formula that we're going to use is stress X is equal to mz over izz multiplied by y. Okay. And by looking at where element H and element K is, right, you know that element H is going to be in tensile, or we just put positive, right? Because it's above the what? It's above the centroid. Element H is above the centroid. It's going to be tensile. And element K, due to MZ, is going to be 0. Because element K is at the where? Element K, so what we've drawn down here is this is our centroid. That's why it's so important to define where our centroid is. Okay. Anything else to do at this stage? Nothing, but there's one more thing that we know, right? Remember what we said over here. This force over here is parallel to the what? To the centroid. So we are going to have a PX will be equal to 150 pounds. Okay. And this, if we were to apply the formula, stress X is equal to PX over A, element H will be equal to element K, and both are going to be in what? Tensile. Right? If you look at if you look at down here, it's pulling away also. So it's going to be in a tensile. Okay. So this is what I call in detail analysis. Okay. This is generated based on moment Z at point A. Okay. Now, the next thing that we're going to do, we are going to look at the other plane. So the next plane we are going to do is we are going to focus on we are going to focus on XZ plane. Okay, so now I'm going to take this image again. I'm going to paste down here. Right, so now what I'm going to do is now we are going to, so drawing the transformation again. So this is X, Y, and Z. So now we are going to focus on the XZ plane. Okay, so we are going to now look at the XZ plane. So this is my X. Over here now is my Z. Y, okay, my thumbs is pointing upwards using right hand rule. This is rotation about Y. Okay, so now we are going to look at this. This is the view that we have now. So 4, 4, 6, 2, 4, 6. Okay, and then we have a dot down here. We're going to have a circle. Again, this is just a sketch, pardon me, okay? Okay, so you know what we're looking at now. And then I'm going to immediately draw our elements. So this is our element H. Over here is our element K. And then we are going to draw our green line, centroid of interest. So this is our centroid. Okay. So this is the centroid. Now, by drawing this centroid, you can see something very obvious. You can see now our 150 pounds is exactly in line with our centroid, yes or no? That is why it's generating a what? An axial load. Can you see that? It's so much clearer from here, right? Okay. And then you have your 200 over here. And then you have your 150. No, sorry, 50 pounds over here. And then you have 2, 4. And then you have over here, you have your 150 pounds. Okay. So again, we are going to use the static analysis method of approach, right? So over here on the left hand side, we have our moment, right? Again, this is our moment. Oh, okay, I have to be careful down here. Okay, so that is moment y axis, or what the moment is about the y axis. And again, this is at point A, right? And this is our AX. We don't need to do AX anymore. Okay, so now we are going to take the moment now. Now, as you can see, all the forces, okay, as you can see down here, all the forces, right, are what? Perpendicular to the centroid. So the distance to take now is to the what? To the element. So from here to here is 4 inches. And from here to here is what? From here to here is, I'm mumbling now. That's so bad. 6 inches. Right? Okay. So from here, we are going to take our moment at the dot over here. Right? So moment, so anything that is anti-clockwise. Summation about moment, y-axis, okay, is equal to 0. Okay. And I'll say summation of moment at point A. Summation of y-axis is equal to what? 0. Okay. So now we have minus my at point A. Okay. The 150 is going to do anti-clockwise, multiply by 4, right? And then the 50 is also going to do an anti-clockwise. But the 200 is going to do a clockwise, multiply by 10, and the whole thing is equal to 0. So moment y at point A is equal to what? So it's equal to 150 multiplied by 4, 600. plus by 150 multiplied by 10, 1500, minus by 200 multiplied by 10, 2000. So this we get, wait, I think I make a,
Isn't MYA supposed to be positive on that axis? Just based on the the direction
wait,
of the
hold
other
on,
forces?
hold on, 600. Say it again.
The MYA, when we're doing the summation of for the moments, isn't it supposed to be positive?
No, it's negative because positive is in anti-clockwise direction. Omar, I know where you're confused now. Bear with me, okay? Let me calculate this one first. So this will be equal to 600 plus 1500 minus by 2000. Wait. Positive shear. Oh, I think, hold on. I think, Omar, you might be right because anti-clock, positive shear, positive bending moment. Hold on. 150 multiplied by 4. So 150 multiplied by 4. 600. Let me do the sum first. 600 plus by 1500 minus by 2000. So this is equal to, how come my numbers are different now? Wait. 150 times 4. 550 times 10. Ah, 50 times 100. Hey, so this is 500. Hold on, Omar, I'm not done yet. So 600 plus by 500 minus by 2000. So this is equal to minus 900 Newton meter. Okay, yeah, isn't it? Yeah, you're right. So again, 150 times 4 plus 150 times 10. Okay, so minus 900. So when that's the case, when it's minus, it means that this has to flip over, right? So this is moment Y at A. So from here, this is compression and this is tensile. Okay, now bear with me. Omar asked a question. Omar, you were saying that this should be positive. Is that what you mean?
Sorry, could you which one?
The green one that I highlighted. You say
Yeah.
that no, it's negative. This is a positive shear, positive bending moment assumption. Okay, Omar, you're not seeing this yet. Okay, I'll tell you what you're not seeing. Positive bending moment assumption. Okay, when this is your beam, right? I call this left to right. Okay, analysis from left to right. And the other one, analysis will be from right to what? Left. You look at the arrow. Okay, this is going to left to right. The other one is right to left. Omar, that's clear to you? Omar, keep your mic on. I'm very concerned now. Is that
Yeah, that's
clear?
clear. Yeah.
Okay. So when we do from left to right, the positive shear analysis, this is positive bending moment. Okay. So
Right.
this is positive. When we do right to left, right, which is going this way now, positive bending moment is in this direction. Okay. So for this case, as you see, right, we are analyzing here. So basically we took this off. So the
Oh.
analysis is from what? Right to what?
Right to left.
Left. So when that's the case, this is the positive shear direction. If you do from right to left, which we will do later on, this is your positive shear direction. Are we clear?
Got it.
This is not the same as right-hand rule. Are we clear?
Yeah.
Both are very different things. Okay. And Omar, that's a good question because it's good that you ask now, then when you get confused. Are we clear?
Yep.
And you should have seen this when doing the elastic curve method. Okay, it's the same thing. I taught this in the elastic curve method also. Okay.
Mm-hmm.
Okay, go for 10 minutes break. We come back in 9:02.